In this video, we're going to take a look at data type, control flow, and loops. So this is a pretty big video. There's going to be a lot of content, but don't worry. This is things we're going to use. Some of them you've already seen if you've already done some coding in Unity. After that, when we progress, we're going to reuse them all over the place. So just focus on really like getting the gist of it, and then we'll be able to do more complex things. Let's get started. First thing we're going to look at is we're going to take a look at data types. So data type are type of containers where you can store data in it, and they just accept a specific type. You already know them from C#, so we're just going to go through them a little bit quicker for the primary one, the one that are basics, and we're going to spend a little bit more time with containers. Containers are a little bit more have a little bit more functionality and specifics to it. Okay, so one of the first is an int. So a case number equals 1. So that stores an int. You have the classic float, which is let's say evidence length. Let's say you were measuring the knife of a crime scene, and it's 2.7 whatever unit centimeters. Now you have boolean is guilty, faux sure is guilty is true. You can have store a character, so just a char, which is a letter, and you store it with single quotes, so C, so that way you can store just single character, which could be great for our choice here, since we only want a single letter. You can have string, as you have it here, and I just wanted to show you that a string is in fact just it's the same thing as a character array. Just me not like this, but letters array, which is another type that we're going to see later, that you can initialize like this. So let's say you go C, D, E, and F. Okay, and if you have a string here, you could have C, D, E, F. And what I want to show you, in fact, so we're getting an error here. We're going to deal with that later. I'm going to show you a little loop just for this case. Char letter in let's say letters. And if we do see out of that letter with an N, std that will go end line. If we do this and we do the same thing for the case choice, which is a string, you're going to see that we're going to get the exact same result. Right now I'm going to comment that out because like he says there's an ambiguous that those things are ambiguous, so we're going to comment it out so that we have code that can compile and run. And there we go. We're going to go here, and then you can see the first array I have CDEF, CDEF. So a string is kind of a char array. It's kind of the same things, but it had some sugar on it. Like it's a dynamic. You can add to it, while a char array, you'll see when you have an array that you specify space, you cannot add to it. Usually you're not really going to use a char array, but you might see it in some code that you read, so it's good that you know it exists. Now let's take a look at the C++ containers. Okay, so you're going to have your typical array, which is like this, suspect array. An array has the particular thing about an array is that it is of fixed length, and in the array you can only put whatever data type you put in here. So in here I only have 3 space, which is going to be 0, 1, 2, because the index start at 0, and then I cannot resize this. The next one is going to be vector. So for vector, it's going to be an include. So include a vector. with the vector here, we have a dynamic array. So let's say string here and uncomplete suspect list. This one I don't need to tell the size because I can resize it. So this is pretty nice, and it's usually when you're in C++, I think this is mostly the one you're going to use. Also, another aspect that is important about those two is when it's stored in memory, the three spaces are are side by side. So this is important because when you want to read this information, then when you go into memory to read them, it's quicker because they're side by side. That's the same thing for a vector, but it's a little bit more expensive because sometimes you have to resize, and if there isn't space, then it needs to move around in memory. So that can be, resizing can be expensive. It's just a thing to know, because vector is always side by side. Everything is side by side. So you have also, and we're going to include it, a list. Include list. So for the list, it's another one of dynamic size, like here. So list string suspect list. But this one has one particular thing, is that it doesn't have to be side by side in memory. So it's easier to store because it's going to store it wherever it has any space on the disk, but whenever you read it, then it's going to have to jump around in memories to go to the next one. So that's one particular thing of the list. So it's like if I had a board with my suspect and I use a thread to link them together, that's kind of a list in memory. We can go next with a map. So let's include that. Map. So a map is another kind of, it's dictionary in C#. So you're going to have something that is a key and something that is a value. So for us, it would be like, let's say, suspect information map. So the good thing about this is that you have direct access. As long as you know the key, you can access the information directly in memory. So that's pretty cool. You don't have to go through like a list to see like if so in here you store information that you know you're gonna access directly, and you don't want to each time iterate through memory, through all the spaces in memory to find the information. You know it, you put a tag on it and then you store the information. The next one that we're going to see is a queue. Okay, we're going to include that again here. A queue has the particular characteristic that is always first in, first out. So what I mean is, if I have a string here, clues trail queue, it means that if I want to add information to the queue, I can. It's dynamic. But whenever I want to get information, I'm always going to get the first one that I put in. So it's what we call first in, first out. Let's put it here. First in, first out. You can think about anything, like a queue that you would be at the post office, and then you are waiting in line to get your something package that you receive. So it's pretty self-explanatory, and you have kind of the opposite, which is a stack. So again, we're going to include it. Include stack. A stack is exactly the opposite. You add on top and you remove on top of it. So this one is usually for let's give it a name, like a pile of cases. Okay, so this is what we call last in, first out. Last in, first out. Last in, first out. So it would be like if I was to stack a pile of cases, and then I go, whenever I want to get something, I always get the one on top. So in software, usually you would see that in like, if you have a software that has model pop-ups, like there's pop-ups that can stack on top of each other, but you have to deal with the one on top to kind of get to the one underneath. So yeah, that's when you use these kinds of things. And you'll see that there's sometimes things that we're, because one of the things with software is sometimes we always use lists, but sometimes lists are not the best data structure for that, and sometimes those ones can be pretty useful. The map we use a lot, but these ones I think are underused. The next one is a set. For a set, what it represents is a unique list where value cannot repeat itself. So let's go with set a unique set of suspects. So set is also need to be included here. There it is. So there's a couple of things about this set. So it will let you insert multiple values, but it only keeps unique values. Once it's in the set, you cannot modify it. And the set keeps some kinds of order. It's a ordered list. For a string, it's going to go alphabetical order, and it's going to place them in a numerical order. And you can also specify a struct to kind of put a function in it where it actually compares and decide how the set is ordered, but that's a little bit beyond the scope. But just know that a set exists, and everything you insert in it is only going to be there one time. Yeah, and once the object is in the set, it cannot be modified. That's one other important things to note. So there's a couple other containers, but that's going to be the one I'm going to show in this video, because those are the one you're going to use the most. Now that we know that, let's take a look at different flow control. You know most of them, but before we do that, let's do a little bit of cleanup. So we're going to clean all of this here. So let's clean that. I'm going to clean most of that. I'm going to keep the case number maybe, and we're going to keep the vector. But other than that, we don't want the rest. So let's go and do that. Here we go. I'm going to also uncomment this here and remove, we need the case choice. So let's define a string. By the way, that string can be defined anywhere before it gets used. So to prove that, let's put it here. There we go. So we have our string here. And with this program, if I run it, I'm going to get the same thing I had before. So I can choose a letter. If I do A, A, then A is a great choice. So I have the same thing that I had before. Sorry, I had a breakpoint here, so it stopped, but I'm going to go ahead and close it. Okay, so now what we want to do is, whenever that person has made a choice, we want to output something different. So maybe we want to output the start of the case or something like that. So what we actually want to do here is we want some conditions. So we're going to say if case choice equals A, then we're going to do cout you go to the museum, because this case takes place in a museum, let's say. For us, it could be like, we could do a lot more, but this is what it's going to be. Else if case choice equals B, which is a murder, and we're going to say you make your way to the train station. And we're going to put another end line here. And else in fact, we're going to do another else if, and we're going to handle the else case. So here, usually I like to put it on another line here. So else if case choice equals, equals C. Then we're just going to copy paste this, and we're going to say case C is where is Miss John? Okay, you make your you knock you knock at the door. Let's say you start door duties with the neighbors of Miss John's. Okay, so and else see out. This is not a valid case. And line. Okay. So we're gonna remove this one because we're not, right now we're handling it in there. So this is a basic flow control. That if you're used to it, if you're from Unity, we're gonna start program, and we're gonna go and take C. You knock at the door. So this is your basic if and else if. The next thing we're going to see is loops. So for that, what we're going to do is we're going to rename this just to suspect list. And we're going to create our suspect list based on the case choice. So if we have the case, if we chose the case hey, then we're going to do pushback, and we're going to say like suspect one. And then let's just copy paste this. Let's suspect one. But okay, let's give them name. Museum guard. Let's go with art enthusiast. Don't even know if I wrote that correctly, so let's move on. And dinosaur. I don't know. I think that museum has something historical now. And we can do the same here. So here we're going to say, what is it? The train station. So the train conductor. We're going to have the let's say the let's say passenger one, and then passenger two. Okay, and then if we go to the door, we're gonna say neighbor. Okay. We're gonna say let's say client one. I don't really care about what this is. Client one, client two, client three. Okay, so it was client of Ms. John. So whatever is gonna be after that, we're gonna want to output the list of suspect. So we're gonna say for the first loop, there's two type of for. There's a for each, which iterate through the values, and then a for loop, which is a classic for loop, which iterate through index. So we're gonna do both. And E, which is not really like you're probably not gonna use that very often. The other one is more useful, I'd say, but it's good that you know it exists. For int E equals 0, E smaller than suspect list dot size, and you do E plus plus, and then here you're gonna do cout suspect list square bracket E for the one at index E. So if we do that and we choose the story C again, we have our list of suspect. Now we can also change this list for each for. Now we're going to say the type that is in the list. So it's a string suspect. You do the two dot like this, and you pass in the list. So suspect list. So it's going to iterate through the list and put every single value in there and execute whatever is in here. So we can do again cout suspect, and then end line. So you're going to get the same result, but I feel like this one is a little bit more clearer to me. So if we go here, and this time we're going to say B, we have the train conductor, passenger 1, and passenger 2. So this is the list that you're mostly going to use. There's a couple of other ones. They are more situational, and I don't use them very often. There's a while loop. So you're going to say while a condition. So let's say here we say int, we put E equals to 0, and we're saying while E is smaller than suspect list dot size, dot size. Then you execute here. So we do again cout suspect list at E, and then end line, and then we do E++. And then if you run this, we're going to get the same result. Now we're going to use the A, and there you go. You get you go to museum card. So this one is just a more it's just a situational list, but I never really used it. And there's another one which is even more situational. It's a do, and then you do do, and then wow. So here the only difference between this one and the do while, so I'm going to put some space so that you actually can see it, is that the do while is going to be executed at least once. So it's the same thing as a while, but the condition is tested at the end of this. So it's really, really situational. Usually the for loop are going to cover most of the case. So let's go back to our for loop, my preferred one. So a string suspect in suspect list, and then we are going to output it again. Suspect and line. So this is going to be really 90% of the case you're going to be using these ones. I've really rarely came across a problem that I was like, okay, I need a while or a do while, but I think it's just good that you know that they exist. There it is for our video on data type, data flow, and loops. This is a lot of content, and we're going to reuse it all the time to build software. So we only have, I think, functions and pointer to see in pure C++, then we're going to be able to build something a little bit more interesting. If you like the video, please like, share, and subscribe. Thank you for watching, and I'll see you in the next video.